Howdy.
Thank you for being here. I guess you've learned just about all you need to know about me. But let me repeat a little bit. I moved into this area about 15 years ago.
I'm sorry, I apologize. Your mic's not on. We're going to have your entrance again. So we're going to re-rack. You might step off real quick. Okay, we're going again. All right, yeah, this microphone on the microphone too. So again, please welcome Chuck Moore.
Howdy. Thank you for being here. I moved into this area about 15 years ago from Silicon Valley. And I love it here. I moved first to Sierra City in California, which is on the Pacific Crest Trail, a long trail. I hiked it many times. Then I moved to Bassett's, which is 5 miles closer to the ridge of the Sierra, and then to Incline Village, and then to Carson City, and now I'm living in Wellington. And all this gyration, Reno has remained my central city. The libraries are fantastic, and I'm a great library person. Have been ever since I started this gyra of software development, basically. I invented the 4th language in 1968. That was the same time that C was invented. It was a wondrous creative period for inventing languages, computer languages. It was Fortran, COBOL, ALGOL, Lisp, C. Basically, there are 3 kinds of computer languages. Based on the notation, C, for instance, has expressions like A plus B equals something. It's called infix notation. The operator is in between the 2 arguments. Lisp has a prefix notation, which would be plus AB, with the operator coming first. Fourth is postfix notation, where you have A, B plus. Now, in my mind, that is by far the superior notation. It leads to much simpler programs. For instance, in C, you have a lot of parentheses. In Lisp, you have an enormous number of parentheses. And in Forth, you have no parentheses. So it's a much more natural language for human beings who did not learn algebra in grade school. Algebra teaches you to put the operator in between the arguments, which is unnatural. The operator really goes last. You have a column of numbers, and the sum is at the bottom. The sum is the last thing you develop. So I developed Forth, and I tried to, I used it very profitably in my programming. I convinced a few other people to use it. Back in the 70s, there was quite a community of thousands of Forth programmers all over the world. A lot of them in Germany and Russia and China. And it's faded. There are still thousands of Forth programmers, but they're invisible. Partly because Forth can be used as a trade secret. If you write Forth programs, they'll be smaller, faster, and bug-free. And these are attributes that people don't like to share. They like to hold them close. I took great pride in writing programs that I could use to do things that I wanted to do. Now, I had to write programs for other people in order to earn money, but those were not really satisfactory experiences. It's better to do my thing my way. And one of the first things I did was design circuit boards. So it is very convenient that this slide is up there. I would like to suggest that some of you, some of the younger of you, might like to write their own software. Back in the 70s, that's what you did. You could not buy software. There was no software to buy. And I thought the future would be everyone writing their own software using the most efficient language, the simplest language they could, until Bill Gates came along and persuaded everybody to buy software instead of building it. In fact, his genius was he persuaded you to buy it over and over and over again. And that is the way he corrected the bugs, or lack of features, in the original versions. Force software is simpler than C software. Windows is programmed in C, Linux is programmed in C, OS I think is probably C. There's only 2 languages in the world today, 3. C, Java, and Forth. And you've never heard of Forth. But it is orbiting Saturn. The first program I wrote for my own use was to design circuit boards. And all it required was a small Forth program and the ability to draw rectangles. So that is a good exercise in programming. If you can find a language, any language on a computer that you have, and they can draw pictures, draw rectangles and move them around and make circuit boards. Hey, you can see the rectangles here. Most lines are rectangles, and most well, these are contacts are octagons or hexagons, but they could be rectangles. And you can do something non-trivial, and you can have a lot of fun doing it. And you can add a lot of color, draw color pictures. That's fun. The reason for doing it is that current languages can do everything. C is designed to do everything you want to do. Windows is designed to let you do everything you want to do. Forth does not do that. Forth lets you do anything, but not everything. Forth is what I call extensible. If you want to add a new command to do something you had not anticipated wanting to do, you can do that easily. You can build the language in whatever direction you want to go. Everything isn't there at the beginning, so you don't have that overhead. Now, the overhead is significant. To design a circuit board might take a megabyte of code. In Forth, it would take a kilobyte. 3 orders of magnitude less code. 3 orders of magnitude, not 1%, but 1/10 of 1% the amount of code. I have demonstrated this numerous times. Nobody wants to know. There's a whole industry built up around large, inefficient, buggy software. Starts with Windows. It even goes into the standards committee with this bug they found recently in the secure socket layer. You might say it's shocking. You might say it's fraudulent. You might say it's a conspiracy. But it's good business because people are willing to pay money. It makes a lot of jobs. You don't want a disruptive technology that will put 9 million of the 10 million programmers out of work. But you can write your own software, do your own thing, and gain a lot of satisfaction from it. It's a lot more fun than crossword puzzles. After designing circuit boards, I thought it would be fun to design computer chips. So I took the same philosophy I use with circuit boards, and I shrank it down 3 orders of magnitude and designed a computer chip. It isn't as hard as you might think. In fact, it is really quite easy. All you have to do is draw rectangles. The fact that the rectangles are tiny instead of macroscopic is not important. And you lay out these rectangles nicely, 3 or 4 layers of them, and you have a computer chip. To actually make such a chip will cost you from $5,000 to $25 million, depending on exactly what you're doing. It's really not affordable, but actually making the chip is not important. What you want to do is design it and simulate it and test it in virtual space instead of in real space. And if you get a really hot design that you like and you can convince someone else to finance, then you've got a product. Now we've got a product. We've got 144 computers on a 1 centimeter chip in a very conservative technology. That's what's cost us $5,000 to make in small quantities. So it can be done. Why would you do that? Personally, I'm doing it to prove out how everyone else is doing a bad job. My software is maybe 100 kilobytes to design the chip. Cadence and Mentor Graphics are the standard tools the industry uses to design chips, and they're 100 megabytes. You hear of programs that contain a million lines of code. I know the software used in fighter planes, the F-22, has more than a million lines of code, several million. A million lines of code is mind-boggling. It would be a stack of paper this deep. You can't read a million lines of code, let alone write it. You've had 1,000 people contributing to a million lines of code. Nobody knows what it does. No one person does. It takes the entire corporation to know what that code does. And no one in that corporation can answer the question were you to ask it. You have to trust that somehow it all works together. And we all know how badly it works. The Windows comes out every year, and it's probably a million lines of code. I don't know how big, but it isn't as big as some of the big codes. Big codes are for weather forecasting, for nuclear test simulation, for coordinating the motion of all the ships in the world. There are big problems, and there are big data, but they don't require big programs. You can see this for yourself when you download an app to your smartphone. Apps are 10 megabytes of code. 10 megabytes. If I were to do that in fourth, it would be 10 kilobytes. On the other hand, I would have to program the entire phone in order to get that kind of an advantage. And so far, I've been unwilling to program a smartphone. Maybe I will. I have 144 little computers. They could do it. You do need memory to store images. You need memory for large databases. Memory is a good thing. But memory is not a good thing to fill up with software, because 10 megabytes of code has bugs. 10 kilobytes of code does not. If you want efficiency, if you want compactness, if you want reliability, you want small programs. That means the program can't do everything, but it can do anything. We have written a browser in Forth. It was small. It wasn't as small as I would make it because I didn't like the way they were doing it, but it's possible. You can write an email application. The way phones work, the way everything works in this world, people don't really write software anymore. They take software packages from various sources and stick them together. It's the same way to make software. The software in a cell phone contains a chip which does amazingly many things. A component from here, a component from there, all glued together. This uses 10 times as much energy, 10 times as much area, 10 times as much design effort as it needs to, but that's the way people are doing things nowadays. Not conspiracy. It just seems to be the easiest way to do it. It's the way the corporate managers want you to do it. It doesn't have to be that way. We can do better, smaller, faster, cheaper, and it's up to the young generation coming along to change some of these trade-offs. The way you do it is to write a little program that does something you're interested in, show it off a little bit, improve it, write your own software. One of the things about Forth is perhaps held it back. It's very easy to write a Forth operating system, Forth system. It only takes about 10K of code. Everyone who got interested in Forth wrote their own system. So there's many systems out there. You want to know about it, just do a Google and find all kinds of references. I have a website up there called colorforth.com. That's COLORFORTH. The company I'm working with now is called Green Arrays. They have a website. There's a Forth.com website, which has been around for as long as the internet. Lots of information out there. It's a fun thing. I'm very pleased to have been involved in it. The conventional way of doing things is not always the right way. It was probably arranged as a historical accident. And that's kind of true of Forth also. Forth came along and became what it is, more or less accidentally. If I had not invented Forth, I don't think it would have been invented. It was not a popular way of doing things. There was no great opportunity working there. It's turned out to be a good thing. And I'm very proud of it. And I thank you for listening to me.